Yeah, well, guys, should we go to open discussion now? Should we open this bad boy up?
I mean, Drew seems to have some questions. I wanted to talk to Drew, actually.
Oh, okay, okay.
What's up, Drew?
Morning. I missed you totally. I've waited a couple hours for this, so I got a whole bunch of stuff I wanted to throw out there real fast. But can I do a screen share real quick? Because I did some math and a little bit of reverse engineering on this, UFO metal, and I just want to see if anybody else has seen or thought of this. And then I want to talk about explosion welding. So let's see, electronics and me hate each other. Are y'all seeing something that looks like space metal? Okay. I only seen one picture of this, UFO thing, and Charlie seems to, he thinks it's not even real. So I just kind of took a look at this thing, and on the right, I talked to my buddies we have a scanning electron microscope in the building I work in, and they said that in a scanning electron microscope, the lighter shades of gray are the higher molecular weight. So if I know there's 3 metals in here, the bismuth is the brightest, and then the zinc is the next brightest, and the magnesium is the 3rd brightest. So I just kind of assign the colors to the various layers, and this is this thing that's over here. This is just a picture of the I don't know, the space metal. And then on the left, I just kind of went through here, and there was one.
Oh, Drew, your signal's cutting out on us, sir.
We lost you, Drew.
And officially, for the record, it is UFO metal, not space metal. Actually, space metal sounds kind of cool.
Whole material, aeroshell. I mean, we got to come up. It's the outside.
Yes,
right?
You're right. We have to use a technical word.
A whole material.
I kind of like space metal. It sounds Buck Rogers, though.
Where did he go? It's good to get the clarification. So, like Mark, the
up here.
Oh, there he is. Drew, you cut out. Yeah.
It says my internet connection is unstable. Oh, great.
We were debating the finer points of space metal versus whole material.
Okay, well, whatever this stuff is, first of all, can y'all hear me?
Yeah.
Good. Whatever the stuff is, the one piece of information was that the bismuth was 4 microns thick, and by doing a little, just really quick math, that's 64 microns of zinc and 80 microns of magnesium. Does anybody agree with this, or am I way off in Pluto land?
Well, isn't there a scale on the electron microscope image?
Well, I don't have this stuff. And this is a picture I saw in a download or something. I don't have this stuff. I mean, this is the picture of whatever it was, that woman who had this metal, and she took it to some place and they did a scanning electric microscope of it or something. So this is theoretically a scanning electron microscope picture, but there wasn't any scale on it. This is just a very small, very, very, very small piece of this big picture.
I wouldn't even agree that I've worked on electron microscopes before. This doesn't look like a scanning electron microscope. It looks like a transmission electron microscope. Okay, which is where they take it and they make a little thin film of the material, and I don't know.
Okay, well, I don't know anything about electron microscopes. The one we have at work, you just put something in and hit the button, and poof, it comes up. It's super
good
awesome.
For looking at bugs at.
Yeah, it's the first one I've ever seen that you didn't have to put any gold or anything on it. It just the dead bug is good enough. But it doesn't matter. I don't have this metal, so you're saying that I'm way off base here. This isn't even a reasonable engineering exercise.
Well, no, it's fine. I'm just saying it would be nice if they had the scale on it. That's all.
Yeah, but they don't.
Hey,
so
Drew,
I kind of created my own.
Could I ask you a question real quick, Drew?
Sure.
So in the picture that you have, the really bright line, the really dark line, which one's which?
Yeah, the dark line. No,
sorry. This is bismuth.
Over in the big picture, the one that shows all the layers.
Oh,
Yeah,
I
that
don't know
one.
what's going on with these big dark lines and stuff here. I just picked the first repeating cycle that was in the picture.
Gotcha. Because I was
I
gonna.
figured, I figured that the bismuth was
So
real.
the
This could be
gray-
melted edge. I mean, this could be
so
anything. I don't know.
if the
This
gray, if the gray is the shade of gray is the higher of the molecular weight, then the blue, I mean the black, excuse me, would be the highest molecular weight, I would think.
So what's the white stuff? Is that like an oxide on the edge? On the very bottom left?
No,
I
that's
have,
the
I have
zinc.
no, I ignored
be on the
everything
inside.
except the repeating pattern.
So,
'Cause I
but
figured they
what's
were
the
talking about a
weight-
repeating pattern.
The atomic weight of bismuth is less than the atomic weight of zinc, correct?
No, bismuth is the heaviest. It's heavier than zinc.
Okay, so yeah, you got it backwards then. It looks like. You follow what I'm saying? I'm just,
No?
it's saying image, the lighter the shades of gray, the higher the molecular, the lighter the way shades gray.
I
Okay,
think that it's maybe the magnesium and the zinc are backwards.
right,
Oh,
no.
no, they're not. No, I'm wrong.
No, I was wrong. I misspoke because the white line is the lighter
Heaviest.
of shades of gray.
Yeah, so this should be the heaviest stuff.
That's the
This should be
heaviest.
the next
That
heaviest.
would be bismuth.
So the
And this
black,
should be the lightest stuff.
so the
Yeah.
black, the lightest stuff is the black then, correct?
Yeah, I don't know what's going on down here, so I ignored it.
That might be oxide.
Boron.
This is the very edge of the piece of metal, and who knows? It might have melted when it crashed, or I don't know. This thing could be an onion peel for all I know. I went with the reproducible. There's this white line here and this white line here, and as you go further up into the whatever that is, the corner of the picture, it reproduces over and over and over and over and over again. So I picked a section of the picture that clearly distributed or clearly showed repeating patterns of white line, gray line, darker gray line or stuff. And that was the engineering basis on my analysis. And then I just blew it up and kind of, faked in some dimensions.
So what I was gonna ask you there, Drew, was the two dark lines and then the bright white line on the big picture. Yeah. So in between those, especially if you look at the hump there, it's more visible. There's that the faint line that kind of goes along the whole thing. Is that the interface between the two metals? You can kind of see it between the zinc and magnesium words as well. It's like a faint line where there's
there's like a thin line
between.
here, and that was excellent. I was also thinking that maybe that's some sort of an oxide, because I gotta tell you, when I first saw this picture, I got very excited because our thrust production is we could do this. We could make thrust out of this, but we can't do it unless there's an oxide layer somewhere. So I'm wondering if this isn't some kind of zinc oxide or magnesium oxide or
Wouldn't
something.
the black layer be the oxide? Because that's the lightest area.
No clue.
No,
again,
it's black. I think if I may have a couple seconds here, the brightness is the fact that the beam is being reflected the strongest.
Oh.
So the black material is smaller, or its atomic nucleus wavelength. Sorry, I have goats with me right now. It's nucleus, it's the wavelength of the nucleus is smaller in that material than the other stuff, or than the beam that's giving us the image.
that's
The
my
only
thoughts
thing I can
too.
add to this is that this is whole material that has flown. So the banding in it, that's some form of quantum tunneling because the vehicle's been used. When it's been made, I bet the black layer is like the mother substrate. And then they do a deposition of the zinc and bismuth. Okay.
You're saying, okay, yeah, Aidan, so you're saying that it's warped because it's been flown and it's crashed and all that stuff.
I'm saying the secondary lines are quantum tunneling because it's been flown. It's a residue of quantum. It's like proton migration, but it's material vibration at the resonance frequency of the vehicle.
Yeah.
So you're seeing.
So
That's
Drew, if
cool.
it's okay to ask, you said you got excited. You said we could build this. It'll fly. If there's an oxide, what makes you say that we could build this and it'll work?
Well, not to get into our physics too deep, but basically we have an electrostatic system, which is basically a series of plates, and the series of plates with a little magic tossed in produces thrust. So we have a vacuum gap in the middle between the plates. And when I started talking with Charlie about this, he's like, "Oh yeah, with all metals start out permittivity of like infinity, and then you can do some magic with RF or something, and you can actually lower the permittivity of the metal. So all I need is one high permittivity and one low permittivity separated by a dielectric, and I make thrust. I mean, I do that every day. So when I heard about this combination, I'm thinking if there's a dielectric in there somewhere, which, zinc oxide's dielectric, and I don't know what bismuth oxide is, but it might be, then I could manufacture this stuff. And if it's laid out basically in two plates separated by a dielectric, which is what the three surfaces would be, then I can make thrust out of this. So that's why I got really excited about this about a year ago when we started looking at this mess. And I got really interested when Mark started talking about vapor depositing this stuff. And I talked to a buddy of mine who can actually grow diamond, which is frightening. But he tells me that we are never going to vapor deposit this mess together. He says it's not going to happen. So borrowing a little bit of magic from the space program, do y'all ever heard of something called explosion welding?
Yeah, I've heard of explosive welding.
Yeah, explosion welding is basically you take two pieces of metal and you put them in a vacuum and you put them put on top of each other. And then of course you put explosives on this side and you put explosives on this side and it goes, and you literally blow those things together on a molecular level. They are one. There's nothing in between the two. They're the same thing. And although I don't know how to do something on this level, because the only thing I've ever seen is explosion welded together was 1/8 of an inch thick. But the aliens or whatever, the Area 51 guys, they might be a little smarter at this than I am. So if we can just figure out what the ratios are and how thick this stuff needs to be, which is what I was hoping to toss out there. Do y'all see any fundamental flaws in my math for 4, 64, and 80 micron? Because I'm going to figure out a way to make this stuff.
Isn't that what Hutchinson's doing? Is explosive welding?
No, not that I know of.
Well, I mean, he's using RF to.
The
No,
bottom band, if I may interject, I'm sorry, Michael. I think looking at in the picture on the right side, you look at the bottom strip and you see a crumbly white line, thick gray, bright little thin white, thick gray, and then a black. I bet that's the original pattern and it was reflected within. So that is the way that's got to be the layering. If we could figure out what the black material is, it's smaller than the wavelength of the scanning instrument. That's the mother of substrate. I'm using a nuclear
That's interesting.
term.
I hadn't thought to put any interest at all toward the edge, because I figured it got burnt or melted or
No, that's reflected
in some
within
way.
the ship. That's reflected within. So
okay, well that's even more cool. So all we got to do is get somebody to tell me what that pattern is and how thick those things are, and I'm gonna whip myself up some.
no, it's right there. It's right there. It's the black, the thick gray, the very thin white, and then the very thick gray, and then the outside
you're saying this thick black right here?
Yes, ignore the doubling, ignore the waveform. Like you're looking at quantum tunneling and an after effect of the vehicle being used. Now go move your pointer down to the left-hand corner to that little thin black line. Figuring out that distance, that's a reflection off of whatever the black material is. And that has got to be what it originally looked like. And then they used it a lot. And then you get the secondary effects on it.
Well, in theory, this piece, as I understand it, this piece of metal came from the Roswell bounce site. It didn't come from the crash site. It came from the bounce site. They went out in the desert and they picked up little bitty bits of metal or whatever the hell they did. And supposedly that's where this came from. This is supposedly. So, you know, this could be from an explosion. This could be from a wrecked spacecraft or a, you know, whatever. They forgot to
Which
change
would
the oil. For
explain
all I
the
know.
the squiggly lines that we're seeing. 'Cause it
Yeah.
got crunched up. But
'Cause it got
really, at
crunched
one
up.
point, they were almost perfectly parallel to each other. Drew, I sent you a message in the chat. Maybe
Okay,
you can-
I'm sorry to suck up your time, man. I just wanted to throw this thing out there. Get
No,
some
this is
ideas on it.
useful. Thank you, Drew.
Yeah, I'm really liking it. Drew, I want to ask you, what do you use for, what kind of thermal base heating element do you use for depositing aluminum?
Well, the only aluminum I've ever deposited has been on telescope mirrors. So I go to Midwest Tungsten and I get their super thick tungsten coils. They're about I don't know, that's probably a 1/16 of an inch multi-strand. There's like 7 strands of tungsten and they're kind of wound together into a big ass coil that you could wrap around a pencil. Midwest Tungsten has everything and they have it cheap in their like little trash bucket. Their little, we're going to throw this away. So once you buy it from us bucket, but those are all thermal deposits. So I just hang the little aluminum candy canes on the tungsten, and then I pump, you know, whatever, 100, 200, 300, 400 amps through it. It's just pure thermal deposition. But that was for throwing aluminum onto telescope mirrors. And, you know, I want to mention that the aluminum that's on the tungsten, it gets up to about, I want to say it gets up to around 1000 C briefly.
We'll have to get higher than that in order to vaporize now. Or is the at vacuum? What's the vapor pressure of aluminum at vacuum? Vapor temperature. Did we lose Drew?
90 degrees Fahrenheit. So it's, what is that, about 550 C? So anyhow, it gets hot enough to turn into vapor. I don't know what the exact numbers are. The point I'm making is when it's leaving that coil, that super hot coil, it's moving about a mile a second. So it's not just kind of drifting along, wondering where the next place it's going to go at. It's boom. So, you know, it slams into the glass at a mile a second. And, you know, the glass is only, whatever, 12 inches, 18 inches away.
Right. Another thing I was going to ask you is, what do you do about the glass keeps getting fouled up every time we use the machine? It's getting fouled up. Got to take it apart and clean it out. Is there any?
When you say glass, you mean the portholes that look in?
Well, we have just a bell jar, so yeah, pretty much the portholes.
Oh, you get to clean the bell jar every time.
Yeah.
Have you made up your little bucket of alien blood yet? Which is copper sulfate, muriatic acid, and distilled water.
No, I haven't got that.
That's your best friend. Yeah, you make up a bucket of that stuff. And ridiculously enough, you can actually wash your feet in it and get rid of any athlete's foot. But I wouldn't recommend that. But it's completely harmless. Don't drink it, but it is harmless. And it's there's recipes for it out there for mirror washing, for telescope mirror washing. It's a little, you make it up.
Actually, what it's called, alien blood.
That's what I call it. Yeah, that's what everybody calls it. You look at the stuff and you go, "Oh my God, that is alien blood." But it's basically for stripping metal off of glass, and because you don't want to use any bases, you don't want to use any whatever it is. You don't want to use anything with a high pH. You want to use stuff with low pH. And for some reason you can't just use muriatic acid. I thought you could, but you can't. You actually have to have some copper sulfate in there, and you just put that stuff on with a Q-tip, and it poof. I mean the metal comes off in the black snot, and then you are rewarded with beautiful clean glass. But you have to do it every single time. I got to clean when I do my telescope mirrors, I got a little porthole I look through, a little 8-inch porthole. I got to clean that stupid thing. That's why I always start on the far side of the chamber with the coatings and work my way backwards towards, because I got 12 stations for the heaters.
Is there any other name for it? Because alien blood is just
I don't know. I
up.
guarantee you it's nothing but copper sulfate, distilled water, and muriatic acid. And it's probably 50-50 muriatic acid, distilled water, with about 2 tablespoons of copper sulfate tossed in there to make up, you know, make up a quart of the stuff. Yeah, a quart of that stuff will last. I mean, I made up a quart of that stuff 5 years ago and I still have it. You don't need much. I mean, you just need to wet a cotton ball.
Okay. No, that's very useful information.
Yeah, I mean, that's how you strip telescope mirrors of, you know, whatever you've put on them.
Would that remove also bismuth or magnesium or zinc?
It should remove any metal. It
Any
really
metal
should.
plus? Okay.
Yeah, because the metal isn't really, it's not really, it's not bonded to that glass. It's just frozen on that glass. It starts out life as obviously as vapor, and when it hits that glass, it instantly refreezes into the metal. So it's not stuck on there real well. At least
Gotcha.
not, but hasn't been in my observation. So, okay, so I just wanted to toss that out there. I don't think we're going to be able to, the more I talk to the guy who's, by the way, I got a brand new vapor deposition system coming that looks an awful lot like the one you have.
Oh, sweet.
yes.
I asked you, I sent you a message in the chat. If you could just give me your contact
Oh.
info, because I was looking, I
Okay.
was hoping to get
Yeah,
a name
I
from you.
tried to hook up with you through him, but I somehow that didn't work. I messed it up. Again, me and technology do not agree on anything. So I'm going to shut down my sharing if I can figure out how, and turn this back over to y'all so I can sit back and learn and just be amazed. And I have no idea.
We're
how to
also
shut down.
talking about using cryogenically chilled substrates for the vapor deposition of bismuth.
How do I stop this? Oh, there we go. Sorry. Yeah, I was talking with the guy who does this guy's got 30 years in vapor deposition, and he's done everything. And what he told me was give up on bismuth. He goes, you don't even waste your time. You're never going to do it. And then he's like, yeah, the magnesium, that's a real heavy hitter too. That's going to make a disaster of your system. It's going to go everywhere. It sputters. It's all bad. He said the other stuff was okay. So you know, for what I'm messing around with right now, I just do the copper and
Right, so for the
nickel.
magnesium, the sputter material, the one that sputters all over the place, Lesker, the company something Lesker, they have a boat material. It's basically like a
KJ Leskers.
yeah, KJ Lesker, yes, Kurt Lesker. So it's basically like a tube, and there's a hole only in the center. So the metal goes in there, and it can only come out from one point as a vapor. So
Yeah, I've got that.
Yeah,
The little boats are made out of tantalum, and you got to pump about 1,000 amps through them, and they glow white hot. And you really want to have a big, bad to the bone power supply for that. I'm talking a serious old welder that can put out 2,000 amps at 12 or so volts. So, I mean, that's what you need in order to get that bismuth hot enough. It's just like trying to put silicon dioxide on something to do thermal transmission. That's why I'm looking into RF sputtering right now. I don't know anything about it, but I talked to this guy and he goes, you got to give up on the sputtering of bismuth. I said, I can't. I got to make this, you know, spaceship stuff. So he's like, yeah, find a different way to do it. But anyhow, that's why I'm also starting to look into the explosion lamination. I think there's something there. I don't know how to do explosion laminations.
I don't think you can do that accurately, though.
I don't know that you can or can't. I know you can buy a layer of whatever 64 micron zinc, and I know you can whatever. I guess you could mill out a sheet of 4 micron bismuth. I don't know. I don't know how this stuff would be thinner than it'd be transparent at that layer. I don't know. I don't know how to build this spaceship stuff yet. But the guy's telling me that vapor deposition of bismuth is right up there with making diamond, and he spent 20 years learning how to make diamond. Yeah,
Right,
so
right on.
you know, this guy knows a lot more about this stuff than I do.
Just do me a favor, go into the chat. I was asking you for contact info,
yeah,
so we can touch base after the conference and not bore everyone with the.
Yeah. Okay. Yeah. Yes, I will. Okay. Yeah. Sure. Thanks.
All right, thank you very much, Drew.
So I am ready to hear about the rest of your awesomeness.
I think, Drew, I think what you were talking about was pretty awesome. I think that we see, look, I see Jared nodding. I think there's some awesomeness going on right now.
I need to go check on the 3D printer. I'll be right back.
Okay, there goes the awesomeness. It just left. Well, we tried.
I just want to reiterate my point. Like next time you look at Art's parts and you look at the pattern on the side, understand that it's used, it's flown hardware, and that it's, you know, that vehicle, like if you've seen, they can jump, they can go from point A to B, so instantly with no distance between them. So I think the reverberation, the outward layering is an effect within the metal of it doing its, you know, these movements through space-time that we think are impossible to do. And I'm pretty sure if you go to the small thin part and you get down to that pattern and we figure out what the black element is, that's all I got. That's out of the brainstorm, but that's key. Like go look at the inner layer and find those dimensions and remember that it's like a reflection from within. So you could go and look at the original thickness and do a scaling, like a mathematical scaling to get the original material that they made within the factory before it flew. Capiche? Does that make sense to anybody, or?
Aidan, I had a question for you regarding that. You're saying because it's used, it will have changed somehow. Are you saying that the thicknesses of them will change? Or are you saying the composition will have changed? What do you think flight changes?
I have that in my favorites. Let me see. I've looked at it quite a bit. It's the reflection, the waveform. It's an outward waveform, frozen. Like if you look at it, there's a bunch of, you can see it's in triplets, and then there'll be another real thick white line, and then you'll see, you know, it's in triplets again, and then another thick white line. And that's an outward, that's the field affecting the material until it's tuned, or it's a byproduct of the vehicle doing probably the space jump, the folding space and going from point A to B in no time. That's my gut feeling on that. And that
I have an observation regarding that then, because synthesizing things. So two parts. One, the triple repeating part, this is numerology for you. The UAP X Terror in the Sky team noticed triple repeating gamma ray bursts coming off of a craft. It would be interesting if there's a relationship there. The second part is that from what I've researched about this, can't remember where, the bismuth component is because that is what is either trapping or in some way altering the magnetic field. The bismuth is for altering the magnetic permeability of space-time, you know, in such a way as you're able to actually fold the space-time. At least that's the gist that I've gotten. It could be way off the mark.
I mean, we're not playing around with muons, so bismuth may behave differently with muons than with electrons. We're just still playing around with electrons, and we haven't gotten into the electron generations or the generations of matter. So that's my guess, is like they do something, they take the energy within the flight reactor up to the muonic or tauonic state, and that gives them that like bink, like, and then it's, you know, space-time goes no, or the vacuum energy goes, that's enough, back to electron state. And you're
okay. I just want to toss something out there. Our stuff is all sublight. Okay, it's all very, very common physics. So we can make thrust electrostatic fields with variable materials all day long, believe it or not. And so I'm thinking that this is their sublight impulse engines, because that's basically what I've developed. So this falls directly into a really sweet version of the stuff I play with every day. I don't know how to make this yet, and I don't know exactly what the little dark lines and stuff means because I got lost in that conversation. But none of this had anything to do with warp drive, which I hope somebody figures out because I don't have a solution to that. I can supply y'all with an impulse engine to move that doesn't need any reaction mass going anywhere. The whole warpy thing is, you know, I hope somebody figures it out. So the short and long of this is, I think this is part of their impulse engine. I think this is how they kind of hovered and maybe zipped around left and right, and bounced off of
Yeah,
small
no,
mountains.
I get that from the crop circle language and discussions with some aerospace mentors, and it's that magnon. It's the magnon physics, right? It's there are the magnon is the primary field, right? It's a spinning field around the vehicle, and they're using a combination of them so they get fourth wave mechanics. If Jeremy is listening, so you have a couple magnons or three magnons spinning around, and they align the polarities so it goes vink, and it goes in the direction of the strongest field where the patterns are interacting the strongest, and the craft gets pulled that way on the XY plane. The black line, Michael said, I think the right type of scientific instrument, but it's the scanning method and it's the beam that they used. So the black line is below the beam width of the tool that they use to do the scanning of the metal. So that's probably, that information's got to be out there. It's dark because there's nothing for the beam to reflect off or reflect to, but it's still physically there. If we're dealing with reflected electric fields off of the material, beam mechanics, we need somebody with a laser technician degree.
Okay, so you're saying that there might be bunches of layers where that black line, the thick black line is, there might be a bunch of layers, but they're all just too thin to be seen by the, however the thing scanned it?
No, it's got to be the same material. It's just the nuclear size, the nuclear frequency was smaller than either the detector or the beam, so it wasn't getting stimulated. You're seeing an absence of re-emitted electrons. I don't. We need
like
to
metallic hydrogen or something silly. If something so tiny, or whatever. I guess lithium maybe. I don't know. I can't remember what number 3 is. And it ain't helium.
Mhm.
So, but you're saying it's something with a tiny. If it's dark. If it's super dark, it's going to be a really small molecule.
Yeah.
Like
smaller than whatever the beam width was that they
Yeah.
were using in the telescope, that instrument, that it's a microscope.
Okay, well, magnesium isn't particularly huge. I mean, it's what, number 4 or 5 or something.
A bit higher than that.
Okay, so
It's above. No, it's in the
12.
20s, I believe.
I
okay.
posted it's 12.
12. Okay.
Okay, so that black line might be something, whatever the first metal one is.
Boron.
Lithium?
Okay. Oof, that would be scary.
Yeah, it might be lithium.
What if it's carbon?
Oh.
TNT forest.
Yeah, that would be interesting.
It seems like it'd be super reflective if it was carbon.
Well,
I'm just guessing. I really don't know much about scanning electron microscopes, but
I don't know either. Maybe
it's really intriguing. But again, my thoughts are that this is part of their fly around atmospheres and whatever.
Yeah, Stanton Friedman said to think about the vehicles, and like the long cigar tube shaped ones are aircraft carriers, and the little discs are cruising around. They're like the F-18s, or probe ship is another word. So you have
I would look at the little ones as drones,
Oh no, those are the spheres, Tim. I'm
sorry.
sorry. I mean,
no,
Drew,
that's
I've been around Albuquerque and I've got video. I've seen crewed platforms that act intelligently, and then they have these smaller spheres that they release. So yeah, anyway, so I don't want to be step on your politeness, Tim, but
no, that's okay. I was thinking spheres, so
okay.
Yeah.
Well, we don't.
Well, this is amazing.
I have one more thing. I hate bringing up numerology, but I can't help it. So if it was 100 microns, I know you said 60 and 80. If it was 100, that would be right around 3 terahertz, 3,000 gigahertz. Going back to the, 2,995 megahertz signal that was detected by the bomber back in '57. or not the bomber, the early radar ship that they had flying around Alabama, Louisiana, Texas, somewhere around there. It's like one of the only UFO reports we have where we actually have hard RF.
I think it was an
frequency data.
AWACS plane. I think it was an AWACS.
I think you're right. Yeah, it was an AWACS, and it was like one of the first ones because it was in the 50s. Anyways, if they had this frequency where you're getting multiple wavelengths within a single thing, or you're doing even better fractional wavelengths within a single thing, they were doing 1/20th wavelength type thing. That might be another aspect to consider for the distances used for the thicknesses of these, is that those frequencies, you might want to cross-reference those against the already known frequencies that are out there and see if you can't make a match.
Yeah, I don't actually understand how radar works or any of the stuff you just said, but I got intrigued because you have a way to convert the thickness of materials into the frequency it takes to excite them or something?
So I'm not actually going off of the RF frequency propagation through a material. I'm doing free space propagation. So the free space propagation measurement in 57 was 2,995 megahertz to 3 gigahertz. It was like in that window. And it had a 600 hertz beat to it. So what I was suggesting was that when you're looking at that layered material you have, if you look at those thicknesses, we convert over to the actual radio signal wavelength, right, between those two boundaries. It's treating it like a non-uniform antenna. So when the frequency is going from layer 1 to layer 2 and it's transmitting through there, it only needs to be like 1/20th of a wavelength of that material propagation. And then on the next material that has a different permeability, a different wavelength propagation ratio, right? That's got to be some ratio, some fraction of the one before it, because you're getting these waves that are propagating out through the thing if they're using RF. So as the radio wave is going through, it's like not full cycle, it might be partial cycle, because we're looking at, for this being so small at 100 microns would give you 3 terahertz. They were measuring 3 gigahertz, right? Which is a much thicker sample. Would be that if we're using whole wavelengths. But that's why I'm saying that if the 57 saucer had this stuff in it and not thicker stuff, it must be using fractional wavelengths.
But what we're missing on the thicker and thinner thing is like some ships glow red, some ships glow blue, and some ships glow yellowish orange. So there are different materials within the field effect propulsion. So we don't know what color.
That could also be ionization of the air. That could be saying not impulse, instead saying there is some warping taking place. That could be light frequency Doppler effect being slowed down as it's
good point. Okay.
So that's why the
Hey, well,
MUFON case 7.4.
If it is, if these guys are like anything like mine, even though I have ground shielding all around my entire thing, I mean, it's inside an ITO box and it's got ground plates and all the fields are trapped, whatever, mills away from each other. It's still got this stupid field coming off of it. If you're operating that thing in anything even remotely like an atmosphere, it's going to glow. I don't care if you got stealth technology or whatever. You're putting 10 to the 8th, 10 to the 9th, 10 to the 10th volts per meter fields. They're leaking a little bit or they're leaking a lot, but they're leaking, and it's going to make nitrogen purple, it's going to make oxygen blue. So all this color is equal and whatever. If they're doing what I'm doing, then, and they're not doing it in high vacuum, then they're glowing. They're a neon sign zipping through the air.
That may not necessarily be the case as well for two reasons. One, if they are using some form of metamaterial cloaking where they're able to capture the ionization energy, right, before it escapes out at the boundary of the craft, and then redirect it back in, that's one way that they could be more cloaking. The other thing is force fields. So in the LA Battle of LA, or many other instances since, whenever we shoot at these things, when we shoot at them with projectiles, they don't hit. They stop. They don't get damaged by most of the time by projectiles. So if they have some kind of barrier around them, who knows what they might be able to prevent any interaction between atmosphere and craft's edge.
Yeah, I'll explain that in my presentation later.
What was that, Phil?
I'll talk about force field in the presentation I still got.
On the Roswell, or not the Roswell tip, but the in 1950 there was the Farmington Armada event, and that was a 3-day event with over 500 vehicles, and within that group there was one craft that glowed red no matter what. So it was a command vehicle. I've talked with one of the last surviving members, or we need to get David Marler. He's got that, and he needs to redo that presentation. But there was one vehicle that glowed red within the Armada, and it was, just look it up, see if you can find David Marler in the 1950 Farmington UFO Armada. I'm pretty sure that was the direct response to the Roswell crash. Yeah, I'm done. I got nothing else.
I got one more thing just to toss out, but it has nothing to do with reality. I just want to toss this out there, just so we can say we had one crazier idea than all the others. Our biggest problem is turning our warp drive engine off. I call it, it's the impulse engine. Once we charge this damn thing up, it doesn't like to get uncharged, and it just get all kinds of mirror charges, and it doesn't matter. Turning this thing off is a real pain in the ass. And if we're kicking around the other day about stacking a whole bunch of these things in a circle, and then of course turning it on and basically just generating a spinning wheel, remove the power, and it stays spinning for however long it takes for the charges to dissipate, which is days to weeks. So if you're trying to get some free energy out of the universe, the trick is going to be build a nice wheel that spins, and you put some magnets on it, and you can actually extract power back out by electricity. And the only reason I mention all this is because I had a couple of buds that did this about 22 years ago. And I know this is going to sound like a, spooky tale, but they were all excited about DARPA coming and checking them out on a Friday afternoon. We were having beers with them. They were renting a place in Monday morning. They were gone from the earth. They were gone. The place had been emptied. It had been stripped, painted. Their families were checked out. Their houses were empty. Everything was empty. These two guys disappeared from the earth, and one of them was in the space program, and the other was just a dude that worked in the city. And if it had not happened to two buds of mine, I'd say this is BS. But somebody knows something about, because these guys were basically building what I just described. They had a spinny thing and a spinny thing, and it was in a vacuum, and I looked at it, and I didn't know what it was back then, because this was 22 years ago before I got started in this. But those guys figured out how to spin up.
Can you have their names? Do you have their names? Can you share
Yes,
their
I
names
do,
or
but
no?
I'm not sharing that because I don't.
They're going to come after you.
I don't know. We were just buds hanging out with them on a Friday night, and we got to look at this thing. And
I'll tell you this much: if they were on APEC presenting, nobody would have gone after them because the information's already released.
Right. So I'm not saying obviously it's 22 years ago, but these guys never resurfaced. So people do care. if you come across something that, whatever, it's something really, really exciting, and of course they made the mistake of bringing DARPA in, which is a disaster for anybody that hasn't worked with DARPA yet. That they're freaking useless.
We have people in this group that are working with DARPA right now.
That's sad. Yeah,
So-
I worked
so-
with DARPA for many years.
On that note, I want to try and Mark, can I try and make you the host? This may
yeah, sure.
this may backfire on me, but I have to make dinner for my kid. So
Oh.
yeah, okay. I'm gonna try and make Mark the host. We'll cross our fingers. Oh, perfect. Okay, that works.
Yeah,
Thank you,
Jeremy
sir.
just said, if you find anything, call APEC, don't call DARPA.
Okay, guys, I will be back. I will be back later, but I have to make dinner for the child and all that fun stuff. So
Hey,
Love your
Mark.
background.
Hey,
Yeah.
Mark. Can I have this hypothesis for transdimensional Earthlings that it's like a little short presentation. Would be okay if I do that?
Go
Okay,
for it.
can I go first? I just want to present something I've been asking Tim all day long for that.
Is that okay, Michael, if he goes first?
Yeah, I don't care.
Yeah, I know Philip's in a different time zone, so